Dear students, this is the last video lecture on welded connections. The problems we will take in this particular video lecture. A tie member consists of ISMC 225 at 254.1 Newton per meter is connected to either side of the gusset plate of 12 mm thick. Design the welded plate joint to develop full strength of its tie if the overlap is restricted to 300 mm. So whenever in the problem if you get the overlap is restricted to 300 mm, it is an indication that there is a possibility of getting the problem or to be designed the problem as a slot weld. So whenever the length of the plate is not sufficient to take up the total length of the weld, we may need to create few slots to provide the actual length of the weld. So from the steel table, let us take the values for ISMC 225 at 254.1 Newton per meter. The depth of the section, it is a C section. So C section consists of two flanges and one web. Depth of the section equal to 225 mm, which is called as H. Thickness of the web equal to 6.4 mm. Thickness of flange 12.4 mm. Sectional area 3301 millimeter square. So always in the case of a C section, the web is to be connected to the gusset plate. So the tensile design strength of each channel member is given by TDG equal to AG into Fi by gamma m naught. The design load is not given. We have to do the design for full strength of the member. So which is 3301 into 250 by 1.1, 750.227 kilonewton. Let us assume a shop weld. Now the design strength of the weld PWD equal to LW into TT Fu by root 3 gamma mW. Here maximum size of the weld is given by, it is a channel section, not a rounded edge. 6.4 minus 1.5 works out to be 4.9 mm. Therefore maximum size of the weld for 12 mm gusset plate equal to 5 mm according to our table. Therefore let us provide size of the fillet weld equal to 5 mm only. Now the effective throat thickness is given by K into S, that is 0.7 into 5 works out to be 3.5 mm. Therefore PWD upon substitution gives us 662.80 Lw newtons it is. Now equating strength of the weld to the strength of the channel, we get length of the weld equal to 1132 mm. This 1132 mm we cannot provide if we go for ordinary fillet weld, because here we get 300, here maximum we can get 225, on this side we can get 300. So total it will be 825 mm, but the actual length of the weld to be provided equal to 1132 mm. So almost 300 plus, say 307 mm extra we have to provide. How to provide them? We will provide 2 slots here. We will provide 2 slot in the sense we can provide some distance here, some length here, some length here, and some length here. Totally 4 places we can provide the weld in addition to the actual available. So additional length of the weld is provided by the slots as shown in this particular figure. Now width of the slot let us provide as 25 mm. 25 is the width of the slot. Therefore length of the slot x equal to 1132 is the total length, which is equal to 300 into 2 at the top and bottom plus 225, this 225 minus 25 twice plus 4 into x. Let this be x. So upon calculation we get x equal to 90 mm. So 90 mm is this particular distance. So this is how we accommodated 1132 mm in the form of slots. These problems are also important. Okay. Let us take one more problem. Determine strength of the weld for the joint as shown in the following figure to connect two plates with the cross section 150 by 8 and 150 by 12 mm. The ultimate strength of the plate is equal to 410 MPa. This is the plate we have. Width of the plate is equal to 150 mm. Two plates we have. One is having 8 mm thick and another plate is having 12 mm thick. This is where the welding is done. 8 mm is the thickness of the weld. Here 6 mm is the thickness of the weld. So now let us assume the shop weld gamma mw equal to 1.25 mm 2.25 as the factor of safety. Let the size of the weld for 8 mm plate be 6 mm and the size of weld for 12 mm plate be 8 mm. Let us call them as S1 and S2. Now we have to calculate design strength of the weld. That is given by PWD equal to PWD1 plus PWD2. So from the figure we can calculate the length of the weld for plate 1, which is also equal to plate 2, which is equal to 150 mm, which is given. Now PWD equal to, we have the formula PWD1 plus PWD2. So upon substitution we get PWD equal to 278.375 kilonewton. Only the variable here is S1 and S2. S1 and S2. So in this type of welding, the welding is to be done throughout the width of the plate. Therefore length of the weld becomes 150 mm. Let us go for a last problem. A butt joint, partial penetration and full penetration. Two plates of thickness 12 mm and 10 mm are to be joined by grooves or butt weld as shown in the figure. The joint is subjected to a factor tensile force of 300 kN. Assuming an effective length of 150 mm, check the safety of the joint for single groove weld and double V groove weld joint. Assume shop weld and Fu equal to 410 MPa. I will not discuss much about shop weld and site weld because you know all those things. These are given along with the problem. This is 12 mm, this is 10 mm, this is a single V groove and this is a double V groove. In double V groove there will be a full penetration of the weld. So first let us go for the single V groove welding. In this case the effective length of the weld is given by 150 mm because it is given in the problem. Now thickness of the weld is equal to thickness of the thinner plate. By default it is 10 mm. So throat thickness will become TT equal to 5 by 8 into T, works out to be 6.25 mm. Now strength of the weld is given by the formula LW into TT into Fu by root 3 1.25. So upon substitution works out to be 177.535 kilonewton, which is less than the 300 kilonewton. Therefore it is unsafe. Now for double V groove butt weld, we will check whether it is safe for double V groove weld. In this particular case, there will be a complete penetration. Therefore, the throat thickness will be equal to thickness of the thinner plate itself. Earlier we have calculated in the case of single butt weld, we have calculated throat weld equal to 5 by 8 of T. But here no such calculation involved because of the full penetration. Therefore, throat thickness equal to thickness of thinner plate works out to be 10 mm. Therefore, you calculate the strength of the weld using the formula LWTT Fu by root 3 into gamma MW. Upon substitution, we get 284.06 kilonewton, which is again less than 300 kilonewton. Again, the double V groove butt weld is also unsafe to take up the applied load of 300 kilonewton. So, around 10 to 11 problems, okay, totally 12 problems we have solved under welding. You can try a few more problems by referring to the textbooks also. Any doubts, you are free to ask. Thanks for watching.